So I restarted the video because now this is a more separate video that's going to be more relevant for your homework, which is a lot of what I'm going to be doing in your homework is going to be writing functions that deal with arrays. So now that we've got the basics for arrays down, we need to figure out how can we deal with these things in methods, right? So let's go ahead and instead of doing something like this, where basically we set every index to twice the, rather than doing this in main, let's do this, where we set every value in the array to twice the index in the function, okay? So let's go ahead and write that. So first off, public static void change values. Now, surprisingly, this is going to be a void method because of the way messing around with integers works, or arrays work. Change so change to twice. Sorry, let's just call it maybe twice the index. Okay, so to pass in an array, it's just like passing in anything else. You give it the value type, so we're passing in a bunch of arrays, and we can call it whatever we want. Maybe I'll put in array, and I'll call it R for short. A because it's short for array, and B because I get to sound like a pirate because I'll say R a whole lot. So, all right. And so here's what's very interesting. Now, when we've been dealing with stuff, a lot of the time we've had to return. I can just copy and paste this part in. So now let's just rewrite this, though. For int I is equal to 0. I is less than array.length, r.length, I plus plus. Change the ith value in R to twice the index. And normally I'd be throwing a return there. But now let's go ahead and call this method. Num. So let's go ahead and do twice the index R. It's called nums here. So if we run it, it changes all the values in the array. It changes all the values in num to twice the index. And I didn't even have to return anything. What's going on there? Well, it has to deal with the fact that basically the way arguments are passed around in Java. Okay? So let's go ahead and use something of size 5 here. Something a bit smaller and easier to see. So 0, 2, 4, 6, 8. So remember when I printed out, so first it goes back to what happened when I did this. System.out.println nums. Remember when I printed this out? It gave me it gave me what I called a memory location. It's got bracket I. That's short for integer array, right? Array of i's, which are integers. If I had a bunch of strings, it would have done bracket strings over here at this memory location. And it has to deal with the fact that basically arrays can be really, really big. How big can arrays be? Can they be 1,000 big? Sure. How about 10,000? 100,000? Not getting an error yet. What about 1,000,000 size? Almost certainly. I can create an array of million integers, no problem on a modern processor. 20 years ago may have been a bit of a challenge. 10 million? Why not? 100 billion? Sure. 1 billion? Well, yeah, totally. What about 10 billion? Well, 10 billion, we have a problem. The literal 10 billion of type int is out of range. Well, what if I turned it into a long? Cannot convert from a long to an int. So the maximum size when you create an array, it takes in a size, and that size is an integer. So that means that basically arrays can be basically as big as an integer. So integer.max value. So they can be about that big long, which is, what about, actually, could they be even bigger than that for unsigned integers? Maybe. You'll have to look that up. But essentially, once we get above 2, so essentially arrays can be around billion integers big. But that's a lot. Okay? So now, let's say I've created I create this integer. I'm going to stop printing him out, by the way. Instead, just to prove it, I'm going to print out the last value. And to prove that it works, I'll print out, say, the last value in the array. So system.out.println nums.length -1. Oh, that seems a bit complicated. What's going on? Okay, nums.length -1. Well, month.length is like 2 billion something, and -1 is the last index of that 2 billion something array, right? So let's go ahead and see if I can't my computer can't calculate it. Requester array size sees it exceeds the size that I can set up in my virtual in Java. So maybe if something size, so maybe I have to go down to a more manageable 10 million in size. 100,000, 1 million, 10 million. Rather than printing out 10 million integers, bam. Okay, so it deals with that no problem. Now the question is when I pass this into here, there has to be a design when we were designing Java, or we basically the people being the people, not me, the people who designed Java. But basically when we create a programming language, when anybody creates a programming language, they have to have a decision about how do you pass that stuff around to methods. Right? And there's basically one strategy which is called pass by copy, which means that basically I'll take if I want to pass this to a method, I'll just copy all the values into the method, and then when I'm done, if we need to return anything, we'll copy the stuff from the return value out. Here's the issue with that, right? If we're creating a literal copy of, if we want to do that for integer array, and we want to pass all this stuff in to an integer array, that's going to be expensive. We'd have to copy 10 million integers over, right? And then that would be terrible, right? Suppose that I could handle like 1 billion integers. Then I would have to pass 1 billion integers into this. I'd have to create it once here, and then I'd have to copy them over here. And if I was just planning on changing one value instead of like the entire thing, that'd be 1 billion operations I'd have to do to get one thing done. So it doesn't make sense to copy over 1 million things. Instead, what Java does is that it does something called pass by. Well, technically it is passing by copy, but we call it pass by reference, and it's a semantical argument at this point. And the idea is that if we have a bunch of, let's see, and the idea here is that when what gets stored, so we copy what gets stored into variable. So if we had an int x, right? You were saying this was labeled int x, and maybe you would put 5 in it. And what would happen is that we'd copy that 5 over into the variable when we called it in a function. Like when we passed it into a function, we'd copy the x over, right? And it'd be an independent copy. Well, for objects, for integer array, what gets stored in here? Well, when I declare this, I don't know how big the array is going to be, right? Because remember, the declaration and the initialization, they take separate steps. I could totally do this. So the question is, how big of the variable how big is the thing that's going to put in here? I was talking about this with strings earlier. And the answer is, I don't know. We'll figure that out when we put that in. So for right now, I'm just going to put in null, which means there's no array in here yet. And then when we create the array, I'm going to create it somewhere else in memory. I'm going to create it in a magical location called the heap. Just a heap of memory. right? This is all the memory. Basically, it's just a big floating amount of memory that when you run Java, it says that if it needs to create more, if it needs space to create stuff like a big array, you can grab it from the heap. So say we actually do create this array. Well, what happens is that we go to the heap, and we do that with the new keyword, right? Whenever we say new, that means we're going to be creating something using memory from the heap. So we create the new array over here, and we copy the memory location over here. And it's going to be like located at memory location 0x25183 or something. Okay, it's going to be copied over here from the heap, that memory location. And now, if I want to find out where it is, I just where my array is, I know that my array starts at this memory location. Okay? And now, when I pass it into a function, such as over here, when I pass that into a function over here, instead of copying the whole array over, I copy the memory location of the array over. Okay? The consequence of this, which is the important point to remember, is that if you're passing in a primitive or something, if you pass in a primitive, any changes you make to the primitive are local to the method. But if you make changes to any object like an array, then those changes carry over. You're dealing with the same array here and the same array here, even though we've given it a different variable name. Let's go ahead and demonstrate that. Public static void tweak. Int, we'll take in an array, and we'll take in an int x. Okay? What we'll do in here is that we're going to increment array 0 plus plus. That means that we're just simply going to increment the very first value in the array, right? X plus plus. So instead of running that, I'm going to go ahead and run, I'll create an array of size 5. Okay, and I copied over a print line over there. And now I'm going to call tweak. And that's going to pass, I'm going to pass in my array, and let's go with an int a is equal to 3. So I'm going to pass in my numbers to that, and 3. And then let's go ahead and print out the item at index 0, and we'll print out a, and see what happens there. So before I call this function, array 0 is going to be 0 because all the values are going to be initially set to 0. So I run this, and what do I get? I get, let's go through this. I create an array of size 5. I print out the memory location of nums, which is 435. Okay. Then I create an integer a, and I pass in nums and 3 into this function. Okay. I print out I print out array, which prints out the same memory location, meaning it's the same array, right? That we're dealing with over here. Then I increment array of index. Increment index 0 of that array by 1, and then I increment x. So I print out number 0, the first index over here, which is 1 because we changed it, and then a over here gets printed out, and it's 3. And that's because we copied a, and that's because what happened here? When it's a primitive, we copy the actual value over. But when it's an object like an array, we copy where to find the array, where to find the object. We copied that bit over because we don't know how big that object's going to be. And rather than copying around gigabytes in memory, which would be extremely wasteful, we copy around the memory location. Primitives we can just pass around all day because they don't really matter. That being said, you can create new arrays. let's go ahead and write a method that creates a new array, public static int array, and let's create a new array of int size, or return new int, and this is a short function. Basically, it creates a new array of that size. That's all that one will do. It'll create a new array of size 10. I mean, it's a bit of a redundant function, but the point is that you can create new arrays. And you can return arrays if you need to make a new one. All right. So let's see what else can I torture you with in the next 15 minutes. Because that was just that's a lot of stuff that you're probably not gonna have to refresh yourself on when we get back. So let's go over it here. So I've been dealing with integers. You can totally have arrays of other types here, right? We can have arrays of doubles. We can have arrays of booleans. We went over out of bounds exceptions for the arrays. You can get array elements, right? We can create a new integer array of 8, set 1 to 3, 4 to 99, 6 to 2. X is equal to numbers 1, so x's value is going to be 3. Then set, numbers x to 42. So store 42 in index 3. That's an important bit. I love asking questions like this on the exam. And so does Dr. Fiore. And since we put together the final together, you can almost assume that basically there's going to be problems like this where we do something like this on the exam. Number 6 is 11. So I want to store 11 in number 6. Well, number 6 that resolves to an. So this resolves to a number. What is number 6? Well, let's cross it out and write that in. It's what? 2. So this means I just want to store 11 in index 2, which ends up being what we do. So that's we typically don't do that, but we love asking that kind of question on an exam because it really does test, do you know how arrays work? Okay, typically we've already went through this stuff. It's typical to just assign value, use arrays and for loops together. The big thing to note is that string has a dot length with parentheses. Notice the lack of parentheses for an array. Why does the Javas have an array? Why do arrays have a dot length with no parentheses and arrays and strings have a dot length with parentheses? Well, the answer is because this one's a parameter and this one's a method. But honestly, the real answer is probably something along the lines of that the Java devs are a bunch of trolls who hate you because when you get the data structures, you'll be dealing with collections and they use dot size with parentheses. So then there's three things you'd have to remember. Because Python, which you might get the feeling that I really like Python over this for some reasons, it just solves that by using a len function. And basically, if you want to figure out the length of something, you just throw thing into the len function for Python, and it tells you how big that thing is. Right. So there's also there's another thing we can do. Discard my annotations. There's also one more way we can create an array. We can create an array really quickly, like this. Int new array is equal to, say you already know what values you want for your array, you can do this notation over here. Curly brace, and then put the values in you want, separated by commas. So 4, 5, 6, 1, 2. we'll create a new array with the values 4, 5, 6, 9, 1, 2. And what did I forget? Oh, right. Forgot my brackets. So this creates a new array. Now you can only do this the first time an array you can only do this as soon as you declare an array variable. So I can't do this for nums. I can't use this notation for nums because nums already exists. This only works when you're initially declaring an array. So it's pretty useful. Let's see. So, a couple of different things that you need to know about arrays. They have some limitations. The first thing, we've discovered two of them. The first is that you can't resize an array. Okay? You can't just change the size of the array. I told you that, but we didn't try it out. You can't go a.length is equal to 10 to create a new array of size 10 or to resize the array. Arrays are what we call immutable, just like strings, meaning that once they're created, strings are immutable because you can't change them. The size of an array is immutable. You can't change it, although you can change the contents of an array. The other thing we learned was the third point over here, which is that arrays don't know how to print themselves. If we try to print out an array, it gives us the memory location. And the last thing is that you can't compare arrays with double equals or dot equals, because what that will do is that it will ask, do these two arrays have the same memory location? Do they share the same address? Basically, are these the same blocks of memory we're dealing with? Okay? So A1 is equal to A2. So suppose we create two arrays with the same values. Using double equals will return false because A1 is one block of memory and A2 is another block of memory. And dot equals will return false because they're two different blocks of memory. That's what the array, or when we compare arrays, that's how they care about, what they care about. So, all right. So the last thing I want to go over, or one of the last things I want to go over is a question that you guys had, that I mentioned I wanted to answer, which is, why in the world are we starting with 0? All right. Well, it goes back to the fact that this is all stored somewhere in memory. Okay? All stored somewhere in memory. Right? It's stored in memory somewhere, and it's at memory location. Let's make the math easy and say it's stored at memory location 20,000. Okay? Stored at memory location 20,000. And suppose I've got an array of size, well, whatever, it doesn't matter. Well, I need a way to quickly find my way to insert an index. Right? I want to quickly do it. I don't want to go and count manually. Okay, index 1, index 2, sorry, index 0, index 1, index 2, index 3, index 4. Right? 1, 0, 1, 2. I basically want to be able to kind of just teleport there, mathematically. Okay? So the way we do this is by using indices. And we use a formula to figure out where we are. To figure out, basically, with an integer, I just store it in the memory location so it's easy to look up where it is. But for an integer array, what do I have to do? Well, I have to get to the appropriate slot. 6, 7, 9, 2, 1, 8. So suppose I want to figure out, let's call this R. I want to figure out, I want to retrieve the value R at index 2. Okay? So how does your computer do that? And I'm simplifying a whole lot, but behind the scenes what it does, it says, okay, we know array is that array, that's located at the memory location 20,000. So what I'm going to do to find the memory location of what's at index 2, or to find the value of what is at index 2, I take this memory location. So I use, let's call this variable, let's call this address. A, B. So I take the address, and I add the size of an integer to it, which is 4 bytes, because we're dealing with integers for this example. So then I do 4 times the index that you pass into me. So for this one, if I want to get index 0, all it does is says, okay, address plus 4 times 0, which gets me to here. gets me to memory location 20,000. The next one's going to be, the next integer is located at 20,004. This one's located at 20,008. And this one is located at 20,000 and what's the location here? Trick question, it's 20,000C. Because it's being counted in hexadecimal. So, but 20,012 in decimal. So, but anyway, point is that it would go up to this, it would do 4 times index. I'll just simply use decimal notation because we haven't dealt with hexadecimal yet. So, 4 times the index is equal to, so here, what I would do is that for array 2, would be 20,000 plus 4 times index, which is 8. So look at memory location 2008 to grab that that value out of it. So it's able to use this equation to do it very quickly, and math becomes extremely easy for index 0 because we just simply zero out the first index, and that's a big part of the reason why arrays started at 0. They didn't have to, but the people who designed the language and optimized it got there first before the mathematicians. So they got to say what to do. Another way you can think of arrays. Okay, so another couple questions. Why are we using this bracket notation here? Well, in mathematics, you may have dealt with vectors. How many of you have dealt with vectors before, right? In physics and that kind of stuff, right? A collection of integers, essentially, or a collection of numbers, right? Now, if you wanted to get something in a vector, you would often use a subscript notation, right? Like if you wanted velocity here, you know, the first thing, sorry, like v of x and then v of y, right? Well, we can't do subscripts with ASCII. It just doesn't work. Subscripts don't work in there. So instead of using subscripts, we use brackets. As opposed to what you would often do for subscripts, which was underscore, but now it just now it just looks like we're asking for the variable v underscore x. So we use subscripts. So we use brackets instead of subscripts, essentially. There. So that's the basics on arrays. Now, when we get back, I will basically do another refresher of this because this was a lot of information all at once, but it's enough to get started on some of the problems and to get thinking about some of the problems. I don't necessarily, so if you can't figure out all the solutions for the homework I just assigned with what I just gave you, that's okay. What we're going to do is that we're going to, I'll be recording some more lectures over the break. I'll throw them online and just watch them before we come back on class. And on Monday, we'll do some exercises in class. And we're going to start, and my goal is we're going to work on some actually fairly boring exercises, unfortunately. But I swear the payoff will be magnificent because those seemingly very boring exercises that we're going to work on, they'll transform into something that's going to blow your mind, hopefully. Or at least make you maybe at least you'll go, oh, that's mildly interesting. I didn't know about that. So yeah, way to undersell. Okay, so